In lesson 4.4 and 4.5, we will be learning about scatter plots and lines of fit. Our learning target for today's lesson is I can interpret scatter plots and determine a line of best fit. Make sure you have the PDF copy of your own notes and are following along filling in the blanks because that is your assignment today, to hand in completed notes. All right, so a scatter plot is a graph with points plotted that shows a relationship between two sets of data. We are going to create a scatter plot using the information from the table. So we're going to take each of these points and plot them on the graph. So notice hours is the x-axis and test scores is the y-axis. Our first data point is 2.5 hours and a score of 68. So we are going to count 2.5 on the x-axis and estimate 68 on the y-axis. It's about right there. All right, next point is 0.5 hours with a score of 71. So 0.5, score of 71. Next one is 4 hours and a score of 98. So if you study for 4 hours, you get a pretty good score. Next one is 3 hours and score of 91. Still pretty darn good. Next one is 0.25 hours, 1/4 hour, and a score of 40. Person could have studied a little more. Next one, 3.5 hours, score of 83. And yeah, that was 3.5. Okay, next one, 2 hours, score of 75. 1 hour, score of 60. 2.75 hours, score of 85. That one's like right in the middle of the box. 1.5 hours, score of 70. And 3.75 hours, score of 93. This is going to be towards the bottom, but still in the middle of that box. All right, so this is a scatter plot. It looks like the more you study, the higher the score you get. And we could even say that there's an outlier right here because the rest of them seem to follow a line around that area. All right, so example 1 shows a scatter plot measuring the grams of sugar and the numbers of calories in 10 smoothies. So sugars is the x-axis and calories is the y-axis. Notice there's a break in both bars there, which means the x-axis starts at 46 and the y-axis starts at 240. A break at the beginning like that is okay as long as you still count by the same interval. All right, so part A, how many calories are in the smoothie that counts 56 grams of sugar? How we're going to find that? We're going to find 56 on the x-axis. There is only one dot where 56 is, and that dot is on 270 on the y-axis. So there are 270 calories in a smoothie that has 56 grams of sugar. All right, how many grams of sugar are in the smoothie that contains 320 calories? Now we find 320 on the y-axis and go over on that line, and it looks like that dot is at 70 grams of sugar. There are 70 grams of sugar in a smoothie with 320 calories. That's a lot of sugar. All right, C, what tends to happen to the number of calories as the number of grams of sugar increases? It looks like they're all going up. So it looks like as the sugar increases, the calories increase. All right, so those random lines I've been drawing that seem to be about where the points are, we're going to actually learn how to draw those correctly. First, we need to know what a correlation is. The correlation describes how sets of data are related. So just like when we were talking about slope, if from left to right the points tend to move up, we're going to call that a positive correlation. If from left to right the points tend to move down, we're going to call that a negative correlation. And if there seems to be no relation at all, the dots are just super random, we can't draw a line, that has no correlation. So tell whether the data show a positive, a negative, or no correlation. First, I want you to look at these and see if you can guess. And then play the video and see if you got them right. All right, so in example A, we have age and vehicles owned. These dots seem to be pretty random. However, you could argue that they seem to go kind of up, which would be a positive correlation. And then temperature and coat sales at a store, these definitely have a correlation, and that line goes down, so that is a negative correlation. All right, example 3 says make a scatter plot of the data. Tell whether the data show a positive, negative, or no correlation. So first, we're going to label our axis and then plot the points. All right, so I labeled my axis. The x-axis is labeled by 1. The y-axis is labeled by 3. If you labeled your y-axis by 2, 4, or 5, that's also okay. Your graph's just going to look a little different. However, no matter how you labeled your axis, this graph definitely has a negative correlation. All right, example 4. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So before we try to find an equation, first we need to make our graph. I'm going to label the axis and plot the points. All right, so to write an equation, we need two things. We're going to write it in slope-intercept form, so we need the slope, or m, and we need b, or the y-intercept. How we're going to do this, we are going to estimate a line. To do that, I want to pick 2 points that show about where the line is. And now it looks like this first point, this one here, is a little higher than all the other points, so I'm actually going to pick that second point, this point, and the last point. And I'm going to draw a line as best as I can, connecting those 2 points. And then I'm going to also draw a line from the top up through the y-axis. All right, so those points that I used were the second one, 2, 15, and then this last one, 8, 5. I'm going to use those 2 points to find my slope. Remember, slope is the change in y over the change in x. So I'm going to plug in those points, and I have 5 minus 15 over 8 minus 2. 5 minus 15 is negative 10, 8 minus 2 is 6. So my slope is negative 10, 6, or I can simplify that to be negative 5/3. All right, and then my y-intercept I can also estimate. It looks like it crosses about at 18 here. So I'm going to say b equals 18. So then when I write my equation, I'm going to have y equals negative 5/3 x plus 18. That is our line of best fit. Well, that's a new word. A line of best fit is a straight line that comes as close as possible to the points on a scatter plot. There are approximately the same number of points above and below the line. This is, of course, ignoring any outliers. Ignore any outliers. All right, so let's make predictions. We're going to practice this a little bit. We are going to draw a trend line. A trend line is the same thing as a line of best fit. So let's say it's about right there. And notice I have 2 points above the line and 2 points below the line. So that's good. Predict how much you should expect to have to pay in repairs for an 8-year-old car. Well, if we keep going with this line, it's going to cross about there. So I'm going to say an 8-year-old car would cost about $800. All right, now let's write an equation. Use the scatter plot above to write an equation for the trend line. It looks like it crosses the graph about here at 100. So I'm going to say b equals 100. That was step 2. Oops. And then the slope, well, let's see. It went from 0, 100 to this last point is at 800. So it went up 700 and over 8. So we're going to say the slope is 700 over 8, which can be simplified to 87.5. So I'm going to say my line of best fit is y equals 87.5 x plus 100. All right, here are some summary questions for you today. What is a scatter plot and how is it used to show correlations? Well, that was in our vocab on the first page. A scatter plot is a graph that shows a relationship between two sets of data, and it's used to show correlation. That correlation is the relationship between them. So correlations can be positive, negative, or none. Those are the types of correlations you see on a scatter plot. Positive is going to increase. So x increases as y increases. Negative is going to decrease. So as x increases, y decreases. A line of fit is a straight line that best estimates the relationship between the data. There should be the same number of data points above and below the line, ignoring any outliers, of course. How do you draw a line of fit on a scatter plot? Well, we're going to estimate which line covers as many of them as we can. That's straight, of course. And then we're going to estimate the y-intercept and pick 2 points closest to the line to find the slope. And how do you determine the equation? Like we just said, you estimate b and then pick 2 points that are as close as they can be to find m, the slope, and then you're going to write your equation in y equals mx plus b.